Okay, so what we've actually just done is a very brief investigation looking at the reactions of metals with water and with acid. And we know that if they react, in both cases we'll see bubbles. In this one we used phenolphthalein indicator, which would go pink because the product is a base. In this one here, we could have done a test for the gas by doing the pot test because it makes hydrogen gas. The four metals we used were lead, aluminium, calcium, and what was our last one? Magnesium. Okay, great. So, what we did is we put them in cold water, and if they reacted, that was enough to do with the water. If they didn't react in cold water, we then used some very hot water, so nearly boiling water, and we're looking for a reaction in those cases. So let's just quickly go through what we observed. Did lead react with cold water? No. Okay, what about warm water? No. Okay, so no reaction. No reaction. Okay, what about acid? Did lead react with acid, with cold acid? No. Did it react with warm acid? Okay, we've got one yes in the room, but mainly got no's, so that's what we'd probably expect. Okay, so there's no reaction at all. So if we were to say, is this a reactive metal or an unreactive metal, what would we say as a conclusion? Unreactive. Good. There's a thing called the activity series that we're going to try and create for these. We're going to find their relative places on the activity series from our results. So that's what our conclusion is going to be. Okay, let's have a look at aluminium. Did it react with cold water? No. We've got lots of no's out there. Did it react with warm water for anybody? No. Okay. So generally we've got no reaction. Alright, and what about acid? Cold acid? Put your hands up if you got one of that with cold acid. No, so no one there. What about warm acid?
Yeah.
Put your hands up just quickly so I can see. So most of the class got a reaction there. Some didn't. Now that's okay if you didn't, because it just would make these two hard to distinguish between, and you'd say that in your conclusion. That's fine. But for most of us, whoops, that was with warm acid only. Okay, so only if it was warm. Right, let's go down to calcium. Did calcium react with cold water for anybody?
Yes.
Yeah, most of us. Great. So I don't need to go on to warm. Okay, so with cold water. So that's pretty cool. That tells us it's pretty reactive. Okay. Some of you might have though decided, hey, let's see if it reacts with acid as well, and that's totally cool. So did it react with cold acid? Yeah, pretty violently, I'd say. So it also reacted with cold acid. Right, and the reason I'm not putting which acid it is there is because some groups use nitric, some use sulfuric, some use hydrochloric. Didn't matter, as long as you're consistent with which acid you used. Magnesium with cold water?
No.
No, we're getting lots of no's there. Did anyone get to react even just a little bit with hot water? Yeah, a couple of groups did. Again, you go with what you observed. So we had two different possibilities here. Some of you did get it with hot water. I will say it probably needed to be hot, not just lukewarm for this reaction to happen. So those that got a no is probably because it was not quite hot enough. But if you got a no, stick with that because we're still going to see a difference here. Did magnesium react with cold acid? Yeah, it did. And this is what we often do. So we could just create an activity series for this quite easily. Which one of these four is clearly the least reactive? Lead. Okay? So that's going to go on our far right-hand side of our activity series because it's the least reactive. Which one is clearly the most reactive? Calcium, because it reacted with cold water. Great. Okay. Aluminium and magnesium, which one do you think is more reactive? Magnesium. Okay, so our order would be this. And I reckon we could justify that using our observations in this table. So we could justify it. Remember, that's an excellence type word. Justify. So you need to say why calcium's there, why lead's there, and why magnesium is more reactive than aluminium, or vice versa. Now, a little word of warning about aluminium. Aluminium is actually a lot more reactive than you'd think. But because it forms its oxide layer so quickly, and because its oxide layer is lustrous and therefore looks like the metal itself, and also because it's so thin, on the outside of the aluminium, you often don't notice it. So it decreases the reactivity for observation. So just be careful with aluminium. If you look on in a book and you find it higher than, say, magnesium, I'm pretty sure it isn't, but if you find it being very high in the activity series, even though it's used for things like aircraft wings and things like that, the reason is that it's got that oxide layer that forms very quickly, but it doesn't take away from its properties. It's one of those special metals. Right, so that's our little overview of our experiment. I hope that's some use to you.